Welcome back to CNC Learning. This video is being posted after a long gap. Last month, I lost my father. He was 79 and continues to live in our memories. In this video, you will learn how to create a stock removal cycle in Siemens and various strategies in using them. Subscribe the channel for more such videos. My name is Rajeev Sreedharan and I wish you a happy learning. Before we see how the cycle is to be defined, let's see the drawing. In a previous video, we have already discussed stock removal cycle for Fanuc. In that video also we have used the same drawing. So here it goes. 50 dia, then there is a straight line, then there is a radius, then there is an angle. And what is defined is the coordinate for the point B. So this area, the coordinate is not directly defined. So for coordinate B, diameter 100 and 60 mm, and here it is 50 mm, and this is where we define our 0. So for Fanuc we have seen how we can define these without having these coordinates with the help of direct radius and angle input. So here in Siemens there is a contour definition wherein you can draw or you can define, which we will discuss in detail. An overview of the program. So the first line is workpiece. There is a blank definition that is only for simulation purpose. And here you see a label. This can be anything, like it can be even your name with colon. Then whatever is written after a semicolon will be read as a comment. And then tool call, RPM, then rapid, absolute coordinate, XZ, and coolant. Then the tool is position where the roughing has to be started. Here the contour definition, contour call, and Cycle952 where the complete stock removal definition is given. So this is how the program look like. Detail again we will see the actual program. So contour definition, contour call, and cycle definition. Blank input will look like this. The blank, here it is defined as a cylinder of diameter 102 and 120 is the total length from here to here, and 100 is from here to here up to job. This is how the contour is defined using contour definition. So using these geometrical elements you can define how the drawing will look like. And the stock removal cycle, if you go into the cycle,
So this is the complete machining, the contour which is defined for this area, then feed rate, retract amount. This shows whether it is a roughing finishing, then how the machining should happen, and then the depth of cut, then allowance in X and Z. Here X and Z, you can see it is kept to 2 mm. That is only to just demonstrate another strategy of the cycle. And here the stock is defined as a cylinder, and here again 2 mm material is left out. Relief cut, if there is any, need to be defined as yes or no for roughing. During roughing, whether you want to cut the relief, that is what relief cuts yes. In roughing you can omit it. Then as I said, the 2 mm which you have defined, stock what is left out in the first roughing cycle. So just to demonstrate how it works, we are using it as a allowance. So the stock removal cycle, consider the stock as 2 mm in X and 2 mm in Z. And after doing this, the allowance, finishing allowance left out would be 0.15 in X and 0.5 in Z. And this is the depth of cut. In X axis 0.5 and Z axis 0.5. First we will see the simulation, how it is being performed. Simulation is being started. Now if we click on the cycle start button, now the stock removal cycle is being performed. Now the next roughing parallel to the contour, you can see that. So here we have named it as semi-finishing. This is being displayed because of the message command. Now next is finishing. This is all about the simulation. Now we will see each command how it is defined. First we will see the blank definition. This arrow, if you click, it will go to the interface. Now here you can see the blank is defined as cylinder. If you click on that, you have several other options like pipe, corner and all. So we have selected cylinder and the diameter is 102. That is the raw material dimension. Then this is what our 0 is defined, and this dimension is the overall length of the raw material, and this is the distance from this face to the job face. Now this is the label, this is the comment, this is tool. So how the tool can be inserted? Say you go to select tool and whatever tools are defined, so those things will appear here. Say you want to select this tool, you can say OK. So you can see that this tool is being selected to the program. Now this is the RPM and spindle rotation, positioning, second positioning. This is the contour call. So here the contour name is defined. This is again as per your requirement, you can define. I have used contour 1, CONT1 I have used. The only thing is that whatever name you are using in the call, the same thing you have to define. So when you say accept, it will come like this.
and the cycle 952, here it is complete. You can use complete and simple, so that here the options will get reduced if you select simple. Now this is the contour which we have defined. The same name you have to put here, and this is the safety distance. You can just put your cursor so that it will show what it is. This is the feed rate, then the machining, now roughing, finishing, roughing plus finishing. So we have selected roughing. Here again the direction can be longitudinal, face, outside or inside. So we have selected according to our requirement, and this is the depth of cut. This is the allowance, finish allowance in X and Z. So here we have kept more allowance because we want to see another function with roughing parallel to the contour. So here again we have selected the cylinder option. So the blank is cylinder. So this much total area is being taken. So here if you keep allowance or contour, then it will accordingly take. So here for the cylinder, we have not kept any further allowance. So whatever is the definition of the contour, from there no additional material is being considered. Relief cut. So you can see if there is a relief, this relief cut no, when you select it will omit. Now our particular profile do not have any relief, so this is not applicable here. When you select accept, it will go back to the program. And we have retracted the tool with the coolant off command and spindle off command and program stop command. This NN2 is again a program label. So for every operation we are keeping one label. This can be again any name. You can use your name with 1, 2, 3 or operation 1, 2, 3, like that you can define. So I just used this. Don't confuse it with N1 and 2. This is not N1 and 2. This is just labels of your choice. Then further here, what we have done is, here we have used contour parallel, here we have used allowance. So we have told that the stock removal is for allowance with 2 mm, 2 mm. So this is the material it consider. And for finishing, we'll go inside. So here we have kept the finishing, so that it does only the finishing, and further there is no allowance, so that it will simply finish whatever contour you have used. And this is your contour. So we'll go in and see. So 1, 2, 3, 4 elements are defined. So this is the start point, 50 dia and 2 mm we are starting. And next is only a straight line, and then an angle, and then again straight. So here we have added a radius, so it will automatically calculate accordingly. So this is how it is defined. We'll again see how these things can be defined using a new program. I will show you. Now we will create a new program with the name test. So now there is nothing inside the program. We are going to do it one by one. So we'll click on various, blank. Here we will define blank as cylinder, 102 diameter. We already there is already a program with these dimensions. That's why straight away it start with that. This is what the dimensions we need. Once I accept, I will get this. Then we have to start by giving the tool call, or you can start your program with a label. So you can say operation 10. Now you can define your tool. Click on select tool. First we will select a roughing tool. This is whatever is already defined on your machine. So there are different tools. Length offset, X offset, everything is defined, radius is defined. Say OK. So the tool is already selected to the program. And then you can define G90, G0, X. You have a blank of 102. So first you are positioning with some safety. So you can do like that. And then again you can call near to the part. So X102, Z2. Now we'll call, so here if you can define your pull and on also. And then we have to use contour call. So here in this ribbon, we'll select contour turn and we'll say contour and contour call. So here we will define as profile 1. I'm just using as profile 1. Accept. And then I will define stock removal. Complete. Here I have to define whatever whatever name I have selected there. The feed rate. This is the roughing. Longitudinal outside. Depth of cut. Here actually it should be the finishing allowances. So just to show you the contour roughing option. So and to have the simulation also accordingly, we'll keep 2 mm, 2 mm. So here we are using cylinder so that the complete roughing will happen, leaving 2 mm stock. Relief cut no, and then say accept. So now you have your cycle 952 defined. Then after your cycle, you can go G0, X, say 200, Z 100, M09, M05 for spindle stop. So here we have missed something. We have not defined the RPM. So here we can give as whatever RPM you need, say 2000, and the rotation command. So here we have stopped the spindle. Then if you want to stop it, you can give a conditional stop or optional stop as per your requirement. Then we'll just call M30. And now something is missing here. We have said profile 1 is the contour, but we have not defined it. So let us attempt to do the simulation and see what it tells.
So here you can see profile 1 program section not found. So yeah, this is what we expect. So because it is not defined, profile 1 contour is not defined. Now let us go to contour 10, contour, new contour. So whatever profile name you have given, the program name, the contour name you have defined there, the same name you have to give. So it the start point. So 50 is our start point, the start diameter, and 2 mm safety in Z we will give. That's all. This is the first command, first point. So we will simply accept it, and then we will move along Z axis. Now we do not know how much you have to go. We only know that in the end there is a radius. So we'll define the radius. So now we do not know this Z, how much Z it has to go, we do not know. So we'll simply accept it. Next is angular line. We'll click on this. Here we know the diameter is 100 and the length is minus 60. And this angle we know it is 90 plus 30, that is 120. That's all. So you can see it is automatically this line and this line, and the insertion of radius it has already taken. Now we'll move again a straight line. So up to minus 60 we have come. Now we'll do minus 80. That's all. Accept. So you can see. Now suppose you want to insert another radius here. You can go here, chamfer or radius, whatever you wish. So now if you want a radius, you can put like this, or if you make a chamfer, it will become like this. So it is an automatic insertion method. So now we will not put any value here, we will keep it 0 only. Say accept. And now the entire profile is defined. So you can see whatever you have missed out, like the X, Z in this case. Now Z you are not knowing, it has already calculated. Here the alternate angle. So the total profile is now ready. You have to say accept. This we are putting after M30. Now if we see the simulation, you can see the stock is there, the machining is being performed. Yeah, now it is gone. So now so far we have only defined this much. We'll go back to the program. Now you can copy and paste this. You can copy this using your regular Windows thing or this mark, and then select and then copy. So we'll paste it here. So this I will change to operation 20. Now if I do not want this tool, I want a finishing tool. So I will go to select tool. I will use a finishing tool. Finishing. So now I am keeping all other things since the cycle call is already defined. This line we can remove. So here same command we are using. Now we'll go inside. All these things are already there. Now this depth of cut I will reduce to 1, and this I need only 0.15 on X and 0.5 on Z, and this cylinder I will use it as allowance, and here I will say 2 mm in X, 2 mm in Z, relief cut no, accept. Now we will again see the simulation. Now the first one, which we have already seen, with the toolpath for the roughing with cylinder option. Now just to hide this toolpath, we will go there. I will use delete toolpath so that my first toolpath is gone. Now this you can see as a new stock. Now we'll run the cycle so that your next program will run. Now here you can see the option is still longitudinal. So go back, click on this, click on this. Here you can select contour, and now it is going the other direction. So you select here, say outside, accept, simulation. So these are the different options. So by doing this you will know. So the first one with cylinder option. Now same delete toolpath. Yeah. Now you can see it is doing parallel. But there are so many cuts. So maybe the depth of cut is not correct. Let us go back and see. Yeah, here this is the depth of cut. So you need to give 1 mm. Now go back and see. Now if you do not want to run this, you can use go to label option, but okay, your simulation, you need to see everything. The first simulation, if you do not run, your stock will not be correct. So again running the first one. Now delete this toolpath, come back. Yeah. Now it is only few cuts. Come back. Now if you want to finish, if you want to have a finish path, you can, this one you can directly change to finishing, and you can say there is no allowance. Now you can see it. Yeah, the first roughing is going on. Then we'll use the same this thing, delete toolpath option. Now we'll see it will appear as 2 mm directly removed. That is okay. Just for simulation purpose we are doing it. When you are actually doing, you need to control the depth. You need to keep only whatever allowance is required, say 0.15, 0.5 like that. Yeah.
So this is how the program is made. I hope you have understood the entire process. So this is how the cycle 952, the stock removal cycle for Siemens, is created.